Hello everybody, my name is Prof. Soborno. I'm Bari from Bari Times Lab, and today we're going to be looking at Physics 161. Not quite any topic. Anyways, today we're going to be looking at waves. What part of waves? Well, let's see. So basically, let's say you have a wave like this. So if you have a wave and it's heading towards a wall, very big, ugly wall, the wave, the air around the wave is going to be less dense. The air around the wave is less dense than the wall. So that means that when the wave touches the wall, it will reflect back like this. Will turn 180 degrees and reflect back. It's also going to turn down a little bit because a little bit of energy, a tiny bit of energy, will be able to pass through the wall. And so, this mustache for the wall was not intended at all. And so, that little energy crossing is going to take some energy away from the rope wave and kind of actually shrink its reach a little. So here's the new and revised wave gonna look like. That's how it's gonna look like. So now, basically, that's how air reflects. Now let's move on to phasing and out of phasing. So let's say that you have this kind of wave. So I'm going to put it like this. And now let's see what's in and out of phase. If we take this point, then this point, then this point, this point, and one cycle should be enough of a sample. So, let's say we take this, copy it, and put it somewhere else. Let's say we put it like one cycle ahead of the old one. So, you see? Now, here, everything's been moved like this, just like that. So, basically, everything is in phase because they're moving in the same direction as they were before. So, this moved there, this moved there. They're only about 1 lambda in difference. And all of them are still moving in the same direction. So, everything's going okay so far. So now, let's say that we have a pond of water. See? A lake. And it's a coincidence, I promise, that this looks like China. I promise this pool was not made in China. So, let's say we take a rock, we give it some shade, and we dip it in the pool. Now, of course, when we dip in the pool, it's not gonna make love with the pool. It's not gonna spread out in any weird wave fashion. What it's gonna do is, from the point it fell, there's going to be a huge circle wave expanding all the way. It's going to lose energy throughout, but it's just a circle wave. So this is how it would look like in an ideal lake with no damping force whatsoever. damping force is basically the force that like tones down the energy. So now this is basically what we're going to cover today, and these three concepts are, so one more thing. So let's say we have another lake. This time we have a huge sky, and this was a point mass, so it's like a point mass wave. This is one broad, wide mass. So as you can hypothesize, when it moves around left and right, it's going to leave waves in its wake. When it moves around left and right, it's going to make a very broad, liney wave. So, these are two different ways of looking at, these are two different types of waves going in and out of phase, the reflection of waves. Thank you everybody for watching. I'll see you next time on Physics Series 162. Thank you everybody for watching. See ya! Diffraction and Doppler effect coming. Oh yeah, I forgot! This video was sponsored by Brilliant! Oh god, they're coming for me!